Welcome to the Deep Dive, the shortcut you need to being well-informed about the astonishing, sometimes frustrating, and truly magnificent complexities of being human.
And today we're tackling the ultimate topic, really, ourselves.
Sounds huge, doesn't it?
It is. But think about it. If you woke up this morning, you experienced this incredible feat of coordination. Just opening your eyes involves light hitting your retina, hormones kicking in.
Right.
And, in the space of maybe a single breath, this whole symphony of biology, memory, emotion, social stuff, it all comes together to assemble the person you call me.
That everyday miracle, as you put it, that's what this deep dive is all about. Our mission today is to sift through some of the best research out there and give you, the person trying to figure out why on earth we do the things we do, a genuine practical user's guide to being human.
Exactly. And this isn't just theoretical fluff. Understanding where our behavior comes from our genes right up to cultural norms, that's maybe the most valuable kind of literacy you can have.
How so?
Well, when you grasp the forces pushing and pulling you, you can navigate relationships better, make wiser decisions, handle stress with more resilience, real resilience.
Okay, so to get a handle on this massive topic, we've broken down the foundations of human behavior into 5 big anchors. Think of them as layers, maybe, moving from the sort of physical stuff up to the social pressures.
Good way to put it.
So first up, we have biology. This is the hardware, right? The genes, the neurons, the hormones, the basic kit.
Then comes experience. That's what programs the hardware. It's constantly reshaping those neural connections based on, well, everything you do, see, feel.
Okay. Then number 3 is emotion. This is the motivational fuel, the engine oil. These rapid fire signals telling you what matters right now, often way before your conscious brain logs on.
Fourth is cognition, basically thinking. That's the steering wheel, how we perceive things, remember, reason, and, crucially, all those predictable biases we carry around that shape our choices.
Right, the mental shortcuts.
Exactly. And finally, number 5, we ground it all in social context. This is like the roads we drive on. Culture, norms, the groups we belong to. They dictate what's okay, what's expected, what's definitely not okay.
That's the map then. Biology, experience, emotion, cognition, social context.
That's our map. So let's dive in at the core, the biological hardware, the foundation for everything else you are and do.
I like the kaleidoscope analogy you mentioned earlier. It feels right. Human behavior creates all these endless, unique patterns. A sudden rage, a deep thought, recognizing a face.
Yeah.
But every single pattern is built from the same basic bits and pieces. The genes, neurons, chemicals we all share.
And those pieces weren't just thrown together randomly. They were assembled over millions of years by evolution, our emotional toolkit, our thinking style. It's optimized not for, say, 21st century happiness, but for survival and reproduction in a much, much harsher world. We have to keep that evolutionary scaffold in mind.
And that starts explaining some stuff that seems really irrational today, doesn't it? Like, why are we so prone to anxiety?
Precisely. Think about our ancestors on the savannah. Anxiety was a lifesaver, a rustle in the grass. It was far, far safer to just assume it was a lion and leg it, rather than hang around thinking, wonder what that is.
So the ones who were jumpy survived.
The genes fueling that quick, fearful, get-out-of-there response gave a huge advantage. They got passed down.
And the problem now is, those same hair trigger alarms are still wired in.
Yeah.
But they get set off by an angry email, or traffic jams, or a bill you weren't expecting.
Exactly. The threat's psychological, maybe symbolic, but the body's reaction, the pounding heart, the adrenaline surge, it's the same ancient physical response.
It's a total mismatch. Modern life, ancient hardware.
That's it, an evolutionary mismatch. And it applies to complex social feelings, too, like guilt or shame, embarrassment. They feel awful, right? But they evolved because getting kicked out of the group, violating norms back then, that could literally mean death. Exile was often a death sentence.
Wow. So those horrible feelings are basically internal alarms, steering us back towards what the group accepts, keeping the social fabric intact for survival.
Pretty much. Now, let's zoom in even closer to the blueprint itself. Genes. It's easy to think, oh, there's an impulsivity gene or an extrovert gene, like a simple switch.
Yeah, people talk like that sometimes.
But the research is really clear. Traits like that come from this incredibly subtle orchestration of hundreds of genes working together.
So it's not one switch. It's like a massive sound mixing desk with hundreds of faders.
That's a great analogy. These gene clusters might tweak, say, your dopamine levels or how sensitive you are to rewards or just your general baseline energy level. Tiny adjustments across the board.
Okay.
And you see this playing out in everyday ways. The sources mention a researcher studying sleep, right? And this woman, Maya, came from a family where everyone just crashed the second their head hit the pillow. Instant sleep.
While the researcher may be tossed and turned.
Exactly. And later studies found specific circadian clock genes linked to these natural sleep patterns. Maya's family probably had gene variants favoring quick sleep onset. Maybe useful if you needed to grab rest whenever you could, like a hunter-gatherer.
Whereas the worrier lying awake might have alleles better suited for, I don't know, late-night guard duty.
Potentially. It's all trade-offs. But the really crucial, hopeful point here is genes influence us, strongly sometimes, but they don't lock us in. They provide the starting script, but they aren't destiny.
Which brings us to epigenetics. This is where it gets really interesting, I think. The idea that our DNA isn't just this fixed code.
Right. We used to think it was set in stone. But epigenetics shows how life experience can actually add little chemical notes, annotations, to that genetic blueprint without changing the underlying letters, the DNA sequence itself.
So what are these notes?
They're tiny chemical tags, like methyl groups, that latch onto the DNA. And what they do is effectively act like dimmer switches, turning certain genes on or off, or just dialing their volume up or down. It's how the environment literally gets under your skin and tweaks the script you were born with.
The rat pup study is the classic example here, isn't it?
It really is. Pups born to mothers who weren't very attentive, not much licking or grooming.
Yeah.
They could actually adopt the calm, relaxed demeanor of pups raised by super nurturing foster mothers. Why? Because that physical touch, that nurturing care, epigenetically changed the expression of genes controlling stress hormones in those pups.
Wow. So the nurturing literally silenced the stress genes or quieted them down.
Exactly. And the implications for us humans are huge. Things like chronic conflict, really rough childhoods, neglect, they can leave these epigenetic marks linked to being constantly on edge, hyperreactive to stress.
But the good news is?
The good news is these tags aren't necessarily permanent. Positive stuff, good therapy, strong relationships, even consistent habits like mindfulness or exercise, they seem to have the potential to recalibrate gene expression to help manage those stress responses. So, yeah, the environment is always highlighting some lines in your genetic code, maybe crossing out others.
So the blueprint can be tweaked. And the circuits that read it, the brain's wiring, that's not fixed either.
Not at all. The brain isn't hardwired like a computer chip from the factory. It's soft-wired. It's constantly remodeling itself based on how you use it. That's neuroplasticity.
And the London taxi driver study is the killer example of this.
Absolutely stunning proof. To get their license, these drivers have to memorize the knowledge. It's this insane mental map of, 25,000 streets, tiny alleys, landmarks, everything.
Unbelievable cognitive load.
Totally. And when scientists scan their brains, their posterior hippocamp, a brain area absolutely vital for spatial navigation and memory, were physically bigger than in the average person.
Noticeably bigger.
Significantly. And here's the kicker. The longer they had been driving, the bigger that part of their hippocampus was. It's like a muscle. You work it intensely, it grows. Direct proof that your brain structure changes based on the demands you put on it.
Of course, the flip side of structure changing is structure being damaged. We can't really talk about the brain and behavior without mentioning Phineas Gage.
Ah, yes. The classic, tragic case. 19th century railway foreman, horrific accident explosion drives a huge iron rod right through his skull.
Through his frontal lobe, specifically.
Mostly the left frontal lobe, yeah. Miraculously, he survives. He can still talk, walk, remember things.
Yeah.
But the person he was, gone. He went from being this reliable, capable, well-liked guy to being impulsive, profane, unreliable, couldn't hold down a job. His personality completely changed.
So what did that tell us so early on?
It was some of the first really stark evidence that specific brain regions are tied to specific aspects of behavior, beyond just basic functions like moving or speaking, particularly the frontal lobes, the prefrontal cortex. It showed that intellect, memory, they can survive trauma surprisingly well sometimes, but character, judgment, impulse control, that's more fragile when the frontal lobes are damaged.
So the prefrontal cortex is like the brain's CEO, the orchestra conductor.
That's a perfect way to put it. It handles the complex stuff.
Right.
Planning ahead, stopping yourself from doing stupid things, weighing consequences. When the conductor gets taken out, the orchestra just plays noise, chaos.
That's a really powerful point. So, okay, let's sum up this first section on biology. The message for you listening seems to be, your genes give you the starting parts list, but your environment, your experiences, they're constantly highlighting bits of that list, shaping how genes get expressed and how your brain wires itself up.
Right.
which means your choices, getting enough sleep, challenging your brain, eating well, they aren't just abstract healthy habits. They're actively fostering better gene regulation, building healthier neural pathways. Nurture is constantly interacting with, nudging, nature.
Couldn't have said it better. Okay, so if genes and neurons are the structure, the chemical messengers are the real-time signals flitting around inside. We're moving from the building blocks to the chemical choreographers that make us feel, react, strive second by second.
And we need to grasp the difference in how they work, their speed and range. The sources used a nice distinction: whispers versus radio broadcasts.
Yeah, that works. Neurotransmitters, they're the whispers. Tiny molecules jumping across microscopic gaps, the synapses between neurons, super fast, thousandths of a second. Very localized effect, like telling a muscle to twitch or signaling a quick burst of fear.
And hormones.
Hormones are the radio broadcasts. They get released into the bloodstream, travel all over the body, take minutes or even hours to act, and they prime entire systems, getting you ready for fight or flight or promoting long-term bonding, that kind of thing. Wider reach, slower timescale.
Okay. And the chemical probably most famous for drive and motivation is dopamine. We hear pleasure chemical, but it's more nuanced than that, right?
Yeah.
It's about anticipation.
That distinction is absolutely key. Dopamine spikes when we anticipate something good, not just when we get it. Its main job seems to be urging us to explore, to seek things out, and, crucially, to learn the cues that predict reward or relief. Ah, so that's the loop with habits, like checking your phone when it dings. The ding predicts potential social reward, so dopamine says, go check.
Precisely. It's the seeking chemical, the drive, the urge, the go-get-it signal. Less about the liking once you have it.
And when that system goes wrong, it's serious.
Very. Too little dopamine in a specific brain area, the substantia nigra, that's the root cause of Parkinson's disease, the severe movement problems.
And too much.
Too much dopamine signaling or signaling in the wrong places is heavily implicated in things like addiction and psychosis. The brain starts tagging neutral things as intensely important or rewarding, leading to cravings or delusions.
The sources had that cautionary tale about the college student using amphetamines for focus.
Yeah, a really striking modern example. Amphetamines work by flooding the synapse with dopamine. So initially, yeah, he got incredible focus, super motivation, aced his exams.
But the downside?
By the end of the semester, he said, ordinary life felt gray and lifeless. Normal conversations, natural achievements, they just didn't do it for him anymore. Why? What happened in his brain?
His brain's baseline for what counts as rewarding or valuable had been artificially jacked up so high by the drugs. Natural rewards couldn't compete. They didn't release enough dopamine anymore to feel worthwhile. It creates this dependence just to feel normal or motivated. It really hijacks the whole evaluation system.
Scary stuff. Okay, moving to serotonin. Often just tagged as the mood chemical, especially with antidepressants. But it's broader than that, isn't it? The great modulator.
Exactly. It definitely modulates mood, but also appetite, sleep cycles, even social dominance and aggression. But the really mind-blowing thing that shows its scope, where is most of it found?
Not in the brain.
Nope. Only a small fraction. Around 95% of your body's serotonin is in your gut, in your intestines.
Seriously, what's it doing there?
It's coordinating peristalsis, the muscle contractions that move food along, and it's constantly communicating with the brain via the vagus nerve. It's maybe the strongest evidence we have for that gut-brain axis. How your stomach feels really does influence how your mind feels chemically.
Wow. Okay, next up, the stress hormone tag team. Adrenaline and cortisol.
Right. Adrenaline or epinephrine, same thing. That's the sprinter. Secreted in seconds flat when there's an immediate threat. Think swerving to avoid a car crash. Heart pounds, blood shoots to your muscles, digestion shuts down. All about immediate explosive action.
And cortisol.
Cortisol is the marathon runner of stress hormones. Takes longer to kick in, hangs around longer. Its job is to mobilize energy stores, releasing glucose to fuel a prolonged response. And crucially, it helps stamp down memories of stressful events.
Ah, so that's why you remember stressful things so vividly. The location, the smells. Cortisol tags it as important, don't forget this, for future survival.
Exactly. Super useful in short bursts. The danger comes with chronic stress.
Right. If that system, the HPA axis, is running constantly.
If you're constantly bathing your brain and body in cortisol because of work stress, relationship problems, whatever, it starts to break things down. Prolonged high cortisol can literally shrink parts of the brain like the hippocampus, messing with learning and memory. And it hammers your immune system. It's sacrificing long-term health for perceived immediate survival.
Not ideal. But on the flip side, The body has its own natural painkillers,
Right.
the runner's high kind of thing, like Carlos, the marathoner.
Yeah, Carlos described hitting that state of flow where the pain just vanished. Pure rhythm, pure focus. That's linked to the release of internal chemicals, endorphins, and also endocannabinoids, which are like the body's own cannabis.
Wow.
They dull pain, create euphoria. Evolutionarily, maybe it helped our ancestors pursue wounded prey over vast distances without being crippled by pain. Today, it fuels incredible endurance feats.
Okay, last one in this section, oxytocin, the love hormone, the cuddle chemical, associated with bonding, childbirth, trust.
And it absolutely does foster trust and bonding, especially within close relationships. But, and this is a really important but, the nuance matters hugely.
It's not all love and light.
Not quite. Oxytocin's effects are very context-dependent. While it boosts bonding and generosity within your group, your in-group, studies show it can also increase suspicion, defensiveness, even prejudice towards outsiders, towards the out-group.
So it's less universal love and more like a tribal loyalty hormone. Boosts connection with us, makes us wary of them.
That seems closer to the mark. It helps draw those social boundaries. But we can harness its power for good, like in those workshops for new fathers they mentioned.
Right, the skin-to-skin contact.
Just simple skin-to-skin contact with the baby was found to trigger oxytocin release in the dads, too. It helps speed up that hormonal bonding, that attachment, making it feel more real, less like just a social role.
Okay, so we've got the biological hardware, the chemical messengers providing motivation and signals. Now we need the steering wheel, which brings us to cognition. Thinking, biases, making decisions. The messy, amazing human mind at work.
And maybe the biggest thing to grasp about our thinking is that we basically have two minds operating in parallel inside one skull. This constant tension between System 1 and System 2 thinking.
System 1 being?
Intuitive, fast, automatic, effortless, relies on pattern matching. It's that instant gut feeling about someone or the experienced athlete just knowing where the ball is going to be without thinking. Happens instantly.
And System 2.
That's the analytical mind. Slow, deliberate, requires conscious effort, burns mental energy. It's like doing complex math, learning a new skill, carefully weighing pros and cons. It's hard work.
And the bat and ball riddle shows the conflict perfectly. Let's try it. A bat and a ball cost $1.10 in total. The bat costs exactly $1 more than the ball. How much does the ball cost?
Okay, so the quick, intuitive answer that jumps out for most people, that System 1 talking, is 10 cents.
Right. Feels right. Fast. But wrong.
Wrong. Because if the ball is 10 cents and the bat is $1 more, the bat is $1.10. That adds up to $1.20, not $1.10. The correct answer, which takes that slower System 2 effort, is 5 cents. Ball 5C plus bat $1 and baller 5 was $1 cents.
It perfectly shows that trade-off. System 1 is fast and efficient, but it trips up on trickier problems designed to fool intuition.
But why do we rely so much on faulty System 1 then? Why did evolution favor it? Because System 2 is expensive. It takes up so much cognitive resource, we just can't afford to carefully analyze every single tiny decision we make all day long, what socks to wear, which route to walk.
We'd be paralyzed.
Totally. System 1 is the default mode, handling the routine stuff, freeing up that precious System 2 capacity for when it really matters, for the high-stakes decisions.
And to make System 1 work quickly, we use heuristics, mental shortcuts. Generally useful, but they lead to predictable errors, these cognitive snares. Let's talk through the big three.
Okay, first, the availability heuristic. We judge how frequent or likely something is based on how easily examples spring to mind.
So if you see lots of dramatic news coverage about, say, shark attacks right before your beach vacation,
you might overestimate the actual risk, feel more scared than the statistics warrant, maybe even cancel your trip. The vivid, easily recalled examples dominate your judgment, even if they're rare. We confuse ease of recall with actual frequency.
Makes sense. Second,
the representativeness heuristic. This is where we ignore the underlying statistics, the base rates, and focus instead on how well something matches a stereotype or prototype in our head.
Like you meet someone quiet, wears glasses, loves books. You immediately think librarian.
Right. Even though statistically there are vastly more salespeople or teachers or accountants out there than librarians, but the person fits the librarian stereotype, so we jump to that conclusion, ignoring the numbers.
Okay. And the third one, anchoring. This sounds important for, like, negotiation.
Hugely important. The anchoring heuristic. An initial piece of information, often just an arbitrary number, acts as an anchor, and it pulls subsequent judgments or estimates towards it.
Like that experiment where people wrote down the last digits of their phone number.
Yes. And then they bid on, say, a bottle of wine. People whose phone numbers happen to end in high digits consistently bid significantly more for the wine than those with low-ending numbers. The phone number was totally irrelevant, but it anchored their sense of value.
Wow. Salespeople must use this all the time, show you a crazy high price first.
Exactly. The sticker price anchor makes the later sale price seem much more reasonable, even if it's still objectively high. It just pulls your perception down from that initial anchor.
It really drives home that our decisions aren't these stable preferences we just look up. They get constructed right there in the moment, heavily influenced by how the choice is presented, the framing.
Absolutely. The framing effect is powerful proof. Think about presenting a medical treatment for 600 people. Option A saves 200 lives. Option B has a 1/3 probability that 600 people will be saved and a 2/3 probability that no people will be saved.
Most people pick A, the sure thing, when it's framed as saving lives. We're risk-averse for gains.
Exactly. Now, frame the identical outcomes negatively. Option C, 400 people will die. Option D has a 1/3 probability that nobody will die and a 2/3 probability that 600 people will die.
Now, people often switch. They choose the riskier. Option D, hoping to avoid the certain loss of 400 lives. We become risk-seeking to avoid losses.
That fundamental asymmetry is captured by prospect theory. Its core idea is loss aversion. Losses just hurt psychologically way more than equivalent gains feel good. Losing $100 feels much worse than winning $100 feels good.
And that explains why people cling to losing stocks, right? They don't want to realize the loss.
Exactly. They irrationally hope it'll come back just to avoid the pain of locking in that loss.
And this non-linear way we treat probabilities, how does that play out?
Casinos love it. We tend to overweight tiny probabilities like the minuscule chance of winning the lottery. The possibility of that huge win feels disproportionately large in our minds. But we underweight large probabilities. We become insensitive to the near certainty of losing small amounts repeatedly in games of chance.
So we're clearly not just cold, rational calculators. Emotion is deeply intertwined with our thinking. It's not the enemy of reason.
Not at all. It's the co-pilot. You need it. The neuroscientist Antonio Damasio showed this powerfully with his patients who had damage to a specific part of the prefrontal cortex, the VMPFC. This area links emotional processing centers like the amygdala with higher thought.
And what happened to their decision-making? Can they still reason logically?
Oh, they could reason endlessly. They could list pros and cons for hours about trivial decisions like when to schedule an appointment or what to have for lunch. But they were paralyzed. They couldn't choose.
Why not?
Because they lacked the emotional gut feeling, the somatic marker that tags options with value, that tells you this feels right or that feels wrong, that signals when enough analysis is enough. Without that emotional input to assign value and prioritize, their reasoning just spun its wheels. It proved thinking and feeling are partners. You take away the feeling, the thinking breaks down.
That's a massive insight. It really underscores that good thinking isn't just about logic. It needs that emotional compass. So the practical takeaway here for you, the listener, when the stakes are high, deliberately hit the brakes. Put in a cognitive speed bump. Pause. Ask yourself, is my quick gut feeling being skewed by one of these biases? Is an irrelevant anchor pulling me? Is the framing making me risk-averse or risk-seeking? Just pausing gives System 2 a chance to catch up.
Absolutely essential advice. Okay, moving to our final anchor. This pulls us out of the individual head and firmly into the world around us. We need to look at motivation, what gets the engine started, and the social context and environment that directs where we drive.
Right. Motivation. What initiates, directs, and sustains our behavior. Usually split into intrinsic versus extrinsic, yeah.
That's the common distinction. Intrinsic motivation comes from within. The sheer joy or satisfaction of the activity itself, the painter lost in the process, the coder loving the puzzle. It's powerful, deeply rewarding, and very sustainable.
And extrinsic.
Comes from outside. Rewards like money, grades, praise, status, or avoiding punishment. Obviously necessary in life. But it can sometimes have a weird downside. The over-justification effect.
Ah, right. Where adding an external reward can actually kill the internal enjoyment.
Exactly. Classic studies. Take kids who already love drawing just for fun, start paying them to draw. What happens when you stop the payments?
They draw less than they did before you ever paid them.
Often, yes, and less than kids who are never paid at all. The external reward somehow crowded out the intrinsic love of drawing. The activity got reframed in their heads from I do this because it's fun to I do this to get paid. When the pay stops, the reason to do it seems weaker.
So how do we foster that powerful intrinsic motivation then?
The research points strongly towards self-determination theory. It argues that we humans have these three fundamental psychological needs. When they're met, intrinsic motivation flourishes.
And those are...
Autonomy,
Mhm.
feeling like you have control over your choices and actions. Competence, feeling effective, capable, like you can master challenges. And relatedness, feeling connected to and cared for by other people.
So if you design work or school tasks or even fitness goals with those three in mind, giving people choice, helping them build skills, fostering connection, you're more likely to tap into that lasting intrinsic drive.
That's the idea. Now, as soon as we step out the door, our motivations, our behaviors, they're instantly shaped by the social world. And the power of groups to influence what we do, think, and feel is just immense, sometimes disturbingly so.
Yeah, this is where we get into conformity, our deep-seated need to belong, even if it means denying what we see with our own eyes.
The classic experiments are still chilling. Solomon Asch's line study in the 50s, so simple, show people a standard line, then 3 comparison lines, ask them which one matches. Dead easy visual task. But he put one real participant in a room with a bunch of actors, Confederates, who were instructed to deliberately give the wrong answer in most trials.
And what happened to the real participant?
Around 75% of them caved in and went along with the obviously wrong majority answer at least once. The pressure to conform, the discomfort of being the lone outlier, was so strong it literally made them doubt their own perception. Social reality trumped objective reality.
Wow. And if conformity is that powerful, obedience to authority is even more unsettling. Milgram's shock experiment.
Still shocking. Decades later, people recruited for a learning study. They're told to act as the teacher and deliver increasingly strong electric shocks to a learner, an actor, in another room whenever the learner makes a mistake.
And the learner protests, screams, eventually falls silent.
Exactly, clearly in distress. Yet, when the experimenter, the authority figure in the lab coat, calmly insists the experiment requires that you continue, or you have no other choice, you must go on, what percentage went all the way?
It was disturbingly high, wasn't it?
65%. 2/3 of ordinary people continued administering what they believe were dangerous, potentially lethal shocks right up to the maximum 450 volts, simply because they were told to by someone in charge.
That's terrifying.
Yeah.
It suggests terrible acts aren't always done by terrible people, but by ordinary people caught in powerful situations. What made them obey?
Milgram pointed to a few key things. One was the diffusion of responsibility. I was just following orders. The experimenter is responsible, shifting the moral burden. Another was incremental escalation, the foot in the door effect. They started with tiny, harmless shocks. Each step up was small, making it harder to find a specific point to say, no, this is too much. The jump from 435 to 450 volts feels less dramatic than starting at 450.
It's hard to imagine yourselves doing that, but the results suggest many of us might. We seem fundamentally wired to fit in.
We really are. Brain imaging studies back this up. When you hold an opinion that differs from the group's, fMRI scans show increased activity in the anterior cingulate cortex, a brain region involved in detecting errors and signaling social discomfort. Going against the grain literally feels like making a mistake. It causes psychological pain.
So if we're biologically wired for conformity and obedience, how on earth do we build resilience? How do we resist when the pressure is wrong?
It takes conscious effort. Maybe 3 things help. First, just awareness. Simply learning about Asch and Milgram, knowing these forces exist, gives you some inoculation. You can recognize the pressure when it happens.
Okay, knowledge is power. What else?
Second, actively practicing personal accountability. Making it a conscious habit to say to yourself, no, I am responsible for my actions here, regardless of what authority says or the group does, taking ownership.
And third, you mentioned something about balancing belonging and uniqueness.
Right. Nurturing optimal distinctiveness. This is the psychological drive we all have to both fit in and stand out simultaneously. We want to belong, but we also want to feel unique. People who resist group pressure will often have a more complex sense of self.
How so?
They have a diversified identity portfolio, you could say. They aren't just their job title, they're also a parent, a musician, a volunteer, a member of a book club. If one group rejects them for dissenting, their entire sense of self doesn't collapse because they have other sources of identity and belonging. It makes standing alone less terrifying.
That makes a lot of sense. Build a wider base for your identity. Now that sense of self, that belonging, it's forged most deeply in our closest relationships, which brings us to attachment.
Yeah, our early interactions with caregivers create this kind of internal operating system for intimacy.
Oh.
John Bowlby and Mary Ainsworth's work showed these patterns, secure, anxious, avoidant, tend to shape how we approach closeness, trust, and dependency throughout life.
These aren't fixed, but they are influential. The example of Matteo was quite moving.
It was. His pattern was classic avoidant attachment. Casual relationships were fine, but as soon as things got serious, as soon as his partner asked, "Where is this going?" implying deeper commitment and vulnerability, he'd bolt.
Likely rooted in some early experiences where closeness felt unsafe or unreliable.
Probably. He learned subconsciously. Intimacy equals vulnerability equals potential pain, so run away. But the hopeful part was that a patient, secure partner helped him rewrite that script. By providing consistent reassurance, not demanding too much too soon, she helped him learn a new pattern, reaching out during stress instead of pulling away. It shows these deep patterns can change with new corrective experiences. Neurons that fire together wire together, and new experiences create new wiring.
And within established relationships, conflict is inevitable. But how we handle it is key. The Gottman Institute's Four Horsemen are famous predictors of relationship doom.
Infamous, really. They are. Criticism attacking your partner's character, not the specific issue. You're so lazy. Contempt, the worst one. Sarcasm, mockery, eye-rolling, name-calling. It conveys disgust, and it's the single biggest predictor of divorce.
Ouch. What are the other two?
Defensiveness, playing the victim, making excuses, cross-complaining. Yeah, well, you never. Basically refusing to hear your partner's concern, and stonewalling, shutting down, withdrawing, giving the silent treatment, physically or emotionally checking out of the conflict.
So what's the antidote? How do couples fight fair?
It comes down to communication skills. Using I statements instead of you statements. So not, "You never clean up," but "I feel stressed and overwhelmed when the kitchen is messy." Focus on your feeling and the specific behavior, not blame.
And listening differently.
Crucially, using active, reflective listening. Really trying to understand your partner's perspective, even if you disagree. Reflecting back what you hear them saying and feeling. So it sounds like you felt really hurt when I said that. When people feel truly heard, their defensiveness drops, their own amygdala calms down, and you can actually start solving the problem together.
Okay, all the social pressure, relationship stuff, life demands. It inevitably leads to stress. We know chronic cortisol is bad. But you said stress isn't just about the external event.
Correct. It's about the cognitive appraisal. Stress really exists in the gap between how demanding you perceive a situation to be and how adequate you perceive your resources are to cope with it.
So mindset is huge.
Absolutely critical. If you reframe that racing heart before a presentation, not as, "Oh no, I'm terrified," but as, "Okay, my body's getting energized, this is excitement." That simple shift in appraisal can genuinely improve your performance. You've turned a perceived threat into a challenge.
So how do we cope effectively, adaptively?
Healthy coping usually involves a blend of two approaches. Problem-focused coping. Tackling the source of the stress directly, making a plan, studying for the test, having that difficult conversation, seeking information. And emotion-focused coping. Managing the negative feelings that come with stress. Things like meditation, exercise, talking to a friend, using humor, seeking comfort, usually need both.
And the traps to avoid, the unhealthy coping.
The big maladaptive ones are avoidance, procrastinating, using substances to numb out, just hoping the problem goes away, and rumination. That endless loop of replaying negative thoughts, worrying, analyzing.
It feels like you're doing something productive, but you're not.
Exactly. It feels like problem solving, but it's just spinning your wheels, keeping that stress response activated without actually fixing anything. It's a feedback loop of misery disguised as thinking.
And finally, looping back to the social world again. Social buffering. This sounds important.
It's one of the most powerful findings. Just the perception of having strong social support, knowing that friends, family, colleagues are there for you, that help is available if you need it. That belief itself buffers the negative effects of stress. It lowers cortisol, boosts immune function.
Even if you never actually ask for help.
Even if you never cash in that favor. Just knowing the safety net is there provides a profound psychological and physiological protection. Belonging is literally good for your health.
Wow. Okay. We have covered a huge amount of ground, from the firing of a single neuron right up to the pressures of cultural norms. We started with this idea that behavior is this constant dynamic conversation between our biology, our mind, and the world around us.
And the crucial thread running through it all is that the blueprint isn't fixed. Because of neuroplasticity, because of epigenetics, because of learning. It's pliable. It's constantly being updated.
So every choice we make, whether it's to engage that effortful system two thinking, or choose a healthy coping strategy over avoidance, or practice gratitude, or even just get a decent night's sleep.
You are literally carving slightly different pathways in your brain. You're influencing which genes get turned up or down. You are actively participating in the construction of your future self, chemically and structurally.
Which leads perfectly into our final provocative thought for you, the listener. You are not just passively experiencing your life, you are actively co-authoring your ongoing story. Think about memory itself. Every time you recall something, you're not just playing back a recording.
No, memory is reconstructive. Each recall is slightly influenced by your current mood, your current knowledge. It gets subtly rewritten every time. This fluidity makes memory adaptable, changeable.
You can choose how you frame your past experiences and, therefore, your future potential.
So the challenge we want to leave you with is this. If all this knowledge only becomes wisdom when it actually changes how you live, what's one habit you have? Or one deeply held belief, maybe one shaped by that ancient evolutionary hardware, or by your cultural programming that you will intentionally choose to examine, maybe rewrite or reframe this week based on what we've explored today?
Something to think about. Thanks for diving deep with us. We'll see you next time.
To get more details about Foundations of Human Behaviour, a psychological perspective, click the below link to get the book. Subscribe us to get more content like this.